Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our student course registration system and an overview of how we're going to go about working on this particular project. So to begin with, this video assumes that you have watched the earlier videos on topics such as arrays and file I/O, but also as we get further into this project, then it will also assume that you have looked at the dynamic memory allocation as well as pointers. To begin with, though, what we're going to do is we're going to focus just on the overall project in this video, and we're going to start by setting up our switches in our executable. So to begin with, you want to obtain a copy of the snips files, including the instructions, the scrs.h, and for this particular example, we're going to focus in on the static array.h, but basically what you want to have is one of the header files associated with a data structure. What you're going to see after this video is that this project will actually span multiple different types of data structures, but we're going to begin with a static array. You also want to obtain a copy of a students.csv file, courses.csv, and registrations.csv. So to begin with, a little bit of background on the project. You are going to be building a basic student course registration system that will allow for you to add and remove students, add and remove courses, and add and remove registrations. Registration will essentially be defined as an active student enrolled in an active class. The one deviation from this concept of add and remove is going to be that in our remove, we are not actually going to delete the student course or registration. We are going to merely move it or identify it as being inactive as opposed to active, much like what you would do in a real-world system where you don't actually delete the user, but you put them in some sort of state that indicates that they are no longer active in the system. In addition, we will also look at how to display a particular student, course, or registration, as well as being able to update the corresponding files. We're also going to look toward the end of the series at some additional features and how you can build on some of these basic features to do things like calculate the GPA for a given student, or perhaps look at the transcripts for a given student, or the enrollment in a given class, or the average grade in a given class. So to begin with, let's take a quick look at some of the switches that will support our project. You'll see that most of them make sense with what I've just described, the ability to display all the students in our system, to be able to display an individual student, to be able to check to see if a student is in fact a valid student, to be able to add and remove, once again, with removing a student, meaning that we simply change their status. And then ultimately, we're going to focus on the ability to sort the students based on one of the fields in the corresponding structure, as well as choosing the order, for instance, ascending or descending. We'll do the same with the courses, the registrations, and ultimately, when you get done, you should have a .c file that corresponds to the main executable, as well as a header file for the student course registration system, and any corresponding functions in the student course registration system will be in the .c file. Now, we're going to get to this much later on in the series so that you can understand the common functions that might be found then with our base system. In addition to that, you'll also want to create or leverage the .h file for one of the data types. You will not want to implement all four in this project. Rather, you can go about implementing them, but you'll want to switch them out. So basically, you will want to have one of the following .h files and the corresponding .c file. Initially, what we're going to do is we're going to focus on the static array. You'll also see here that we have some basic descriptions of what the .csv files should be named, as well as what they should have in them. You'll see this also in the samples that I have provided, the 5 columns, in this case corresponding to the status of the student, the ID of the student, their first name, middle initial, and last name. And so you see here that I provided you a sample set of students, likewise a sample set of courses from our curriculum, and then I have registered one student in one course, and they are in fact active. This particular registration is still unknown, and you'll see I still have the same student ID, but a different course number. And to understand which courses these correspond to, you'll want to go over to the courses.csv, and you'll see that the 2 corresponds to EE 210 that is taught in this semester. You'll also see that there is some duplication in the courses, with the difference being the semester in which they are taught. Now, before you go too far into this project, you'll want to take a look at each one of these CSV files and make sure that you understand the relationship between them and the type def struct that corresponds to the file. So in this case, if we look at our students, you'll see there are the fields that correspond to a student entity. The course has a course ID, course semester, department number, title, and then the number of hours that the course takes. In this case, you'll see here that a co-op has 0 credit hours, and the rest of the courses are for 3 credit hours. In addition, you'll also see that under the registration type def that you'll have a status, and you'll require a student ID, a course ID, and then ultimately we're going to be able to assign the grade to a given student. Hopefully this now makes a little bit of sense with respect to the files that we're going to be using. And currently our student course registration system.h is simply a placeholder, or maybe not a placeholder, but rather contains the type defs that we're going to be using, including the enums and the structures that will ultimately be used in our data structures. And so to begin with, what we want to do is take a quick look at our static array. We'll focus a little bit more on this in our next video. But you'll see then that the static array requires a reference to the student course registration system.h file. And that's what allows for us then to, for instance, reference the student type in our static array. Once again, you'll want to pick one of these structures to ultimately implement your project. We're going to focus mainly in on the static array. So let's get started now on the project. And what we'll do here is, if you notice that I have created a new project called scrs_demo. I've already added the instructions.c that I have provided for you, as well as having created a driver. The driver is pretty bare at this point. It doesn't really have anything in it other than some comments that we'll need to ultimately pick one of our data structures, as I've mentioned earlier. And you see that I've actually included all of the .h files. You will, however, not need to do that. You want to pick one of these 4 data structures: the static array, dynamic array, single list, or double list. Now you will, in addition to our student course registration system.h, of course, have your own core.h. That was developed over a series of videos on YouTube that focuses on things like your string split, your file read, and your file read line. So this video and this project ultimately assumes that you have went through most, if not all, of that series already. You'll see that I have my own core.c, which is my implementation of my core.h. This follows directly along with those YouTube videos. You'll also see that I've went ahead and stubbed in each one of my .c files that corresponds to my .h header files. However, once again, we are not going to be implementing all of these. So rather what we'll want to do is remove or only focus in on the .c files that we will absolutely need. Put another way, you're only going to do the static array or the dynamic array or the single list or the double list. So you will only need the C files and the H files corresponding to those data structures. In all four of those data structures, however, you will require a scrs.h as well as a core.h, and ideally we'll also have an scrs.c, but we will definitely need a core.c. So to begin with, what we want to do is we'll take a look at our instructions, and we're going to focus in on our switches, and we're going to see if we can come up with some commonality between our switches and ultimately how our main is going to handle these switches. So for instance, you'll notice here that they have some rough grouping here of our student course and registration, as well as some of our bonus features, then that also utilize the registration. So ultimately, you can sort of think of this as a tier of switches. First tier, if you would, is going to choose between the student functionality, the course functionality, and the registration functionality. Now, to begin with, I would encourage you to go back to one of your earlier projects. We're just going to pick on our pointers demo, and we'll look at the pointers driver. And you'll see that I have provided then a for loop that simply allows for us to loop through all of the arguments in our main, or rather the arguments that are being passed to our executable. I would encourage you to go ahead and copy that over, or once again, redo it however you want to. Basically, it's just going to be useful in triaging our switches. From there, you can close any of your drivers that you may have had open. And what we're going to do now is we're going to focus just on our arguments. And what I'd like to do is also go ahead and use this as an opportunity to establish our help. So what you can do is, much like in your pointers driver, you can go ahead and create a void help void. And at this point, then what we can do is we can go ahead and stub this function in after our main. And this will, if you want to, once again, go back to your pointers driver, be modeled after the main, the help that we have done in the past. So if you want to, you can just quickly go ahead and borrow a couple of lines to get started. And in this case, the main thing that you want to do here is change, of course, the name to our student course registration system demo. And from there, then we're pretty much set. Probably another good idea, so that we don't have as many files open, is to go ahead and copy over our arguments list so we can make some notes in it. And whether you include it in your main or down here in the help doesn't really matter, but basically just leave it as a set of comments. And optionally, you can go ahead and include these bonus, and we'll see how far we can get with these. Ultimately, the whole goal with the bonus section is that you start to see that you can add additional features pretty quickly, assuming that you have designed your system correctly. All right, so let's go ahead and close out our instructions. Let's go ahead and focus then in on triaging our switches. You can optionally go ahead and close out the additional files here. We won't really be using those too much in the remainder of this video. Instead, what we want to do is think just quickly about the number and type of arguments that we would be expecting to pass to our executable. So if you'll notice here, for instance, that if we are trying to pass the student and display all, that this will result in a total of 3 arguments. I'm just going to simply specify the number to begin with for each one of these. And you'll notice if we're trying to display a particular student, that argument count is going to be 4. Now keep in mind that the executable itself counts as that first argument. So that's RV square bracket 0. But basically, that is going to be included in the argument count. And so what you want to do is take just a second to go ahead and just log then the number of arguments that are going to be needed for each one of your scenarios, particularly when you add a student. So this is going to be 1, 2, 3, 4, 5, 6. And then, of course, don't forget your executable, which will make that one 7. This one will be 4. And this one will be 5. 4 plus the executable itself. You want to continue to do this with all of your possibilities here. Yes, the course now, we should have then 4 whenever we have to specify the course ID. And then 1, 2, 3, 4, 5, 6, 7, 8 plus 1 is 9. We'll have 4 here for the remove, and then 5 for the sort. At this point, hopefully you start to see the pattern. It's pretty similar between our different functionality here. We have, of course, with the registration, we have an additional argument that must be provided for a specific registration, because a specific registration involves both a course ID and a student ID, so that brings the total to 5. Likewise, with the ISA, that's going to bring the total to 5. The add is also going to have a total of 5. And then we have 1, 2, 3, 4, 5, 6 for when we want to update the grade for a given student. If you continue with the number of switches, or the remaining switches rather, you'll see that you have 5 for the remove over registration. Once again, remember that that just simply changes the registration from active to inactive. For the sort, we also have 5. So there's a little bit of a difference between the registration and the student in the course. And then while we're at it, let's go ahead and take a quick look at the bonus switches. In this case, for the registration to display the courses for a specific student, we have a total of 4 switches. For the GPA, we also have a total of 4. For the roster, we will have a total of 4. And then for the average for a course, or the mean for a course, we will have a total of 4. So what I encourage you to do is make a copy of this somewhere. Once again, you can leave this in your help. It doesn't really matter. What I'm going to do is I'm just simply going to copy this over to a notepad file, text file. And that's just simply so that I keep it over here on my other screen so that I can sort of follow along here. And one by one, we're going to go through each one of the switches and attempt to triage them. So to begin with, let's take a look at how we want to start by calling our help. And so right off the bat, what we can do is we can set up an if statement that simply looks at the argument count here. So if, for instance, our argument count is, excuse me, less than 2, meaning that basically the argument count, if we want to put it explicitly, is simply equal to 1. That means we were only given the executable. Then at this point, what we have is an implicit call for help. And we can just simply do it this way by saying help. And that's our first option here. And then, of course, if we somehow manage to get to the else right now, we also have another implicit call for help. And we just want to go ahead and include those at the very beginning. And what we're going to do now is we're going to triage then our other options here using else if. So else if. And what we'll do is we'll start off by looking at the first switch that comes after the executable. And to do that, what we're going to do is we're going to leverage our string compare I. And we're going to compare the contents of argv square brackets 1. And if that matches our /h, well, what we know here is that this was now an explicit call for help, meaning that the user intended to see the help. And at this point, we can also include some other switch combinations if you would like. One other switch possibility here we might want to consider is that instead of the /h, that they put in a /? Either way, we want to have them get help. Now, at this point, what we can do is we can further triage that first switch. And this is where we can sort of leverage the systematic nature of our switches in this particular case. And so what we'll do is we'll take a look at our argv square brackets 1. And if, in fact, they have provided the student as the first tier switch, then we can focus on the student switches. And you can also go ahead and throw in a possibility that, or include the requirement rather, that the argument count is greater than or equal to 3. Where did I get that from? Well, it's because if you notice that none of our student switches accept less, or switch combinations accept less than 2 switches, okay, or 2 or less switches. So in this case, we require 3 switches just to display all the students, and rather I should say 3 arguments, because the executable then is considered the first argument. So this allows for us then to focus on our student switches by simply including in a compound if statement where our argc is greater than or equal to 3, and the first, or the index equal to 1 argument, matches student. At this point, what we can do is we can go ahead and jump to the course by simply copying and pasting, and leverage once again the fact that a course requires at least 3 switches. So in other words, 1 or 2 arguments won't be enough. Once again, I keep saying switches, I mean the total number of arguments, including the executable. And so we have to have at least 3. And then you'll notice then for the registration, we also have this scenario. So what you can do is you can go ahead and set up the third else if here, or rather the fourth, to focus on the registrations. Now, let's go back to our student and let's dig a little bit deeper into the possibilities with the students. And so we can start off with another if statement here. And what we'll do is we'll focus on the display all. And the display all, if you take a look at your notes, requires a total argument count of 3. And We no longer have to check to see that argv square brackets 1 is student, because we wouldn't have gotten to this point if it was not. Instead, what we can do now is we can simply check our argv square brackets 2, and if our argv square brackets 2 matches display, then this means that we want to display all of our students, so display all rather. And so what we can do is we can simply start off by putting a print statement with a note that says display all of our students. Followed by a new line. Under the else if branch here, we can now go to displaying a particular student, which is going to require an additional argument. So our argc is going to be equal to 4, and the string compare I of our argv square brackets 2 must match the display. And at this point, then, it is assumed that the additional argument is the student ID. And so let's make sure that we've got our parentheses matched here. Also take a second to make sure that we've matched them here. It looks as if we've missed a parentheses here. There we go. At this point, then, what we're going to do is simply printf note displaying information for, and I'm going to go ahead and provide a placeholder here, %s, followed by a new line, and then for that placeholder, I'm simply going to include in whatever value we currently have for argv square brackets 3. Now, be careful here. This is going to be somewhat of an assumption here. Basically, we're going to just blindly use whatever value is passed to argv square brackets 3. We'd want to do a little bit more work here, but at this point, then the idea is that we're simply triaging our command line switches. We still seem to have a problem with some mismatched parentheses here. Let's see if we can figure out exactly what we have done wrong here. All right, so perhaps a little bit higher up here. And all right, there is our mismatch here. So 1 second here. If you were following along, you probably saw the typo before I did. I accidentally included a square brackets there in front of my argv square brackets 2. At this point, though, we should be able to display then the information for whatever argument is being passed as our argv square brackets 3. We can do the same thing. As a matter of fact, at this point, we can probably borrow a little bit of the code, but we'll go ahead and walk our way through this one. With the argc equal to 4 for our scenario where we are passing the is a prompt, argv square brackets 2 matches then the is a, and if that in fact matches, then what we're going to do here is we are going to just verify. I'm not going to retype this. We're going to verify that the information exists. Basically, this should return a Boolean or 0 or 1 for whether it's false or true to whether or not a particular student exists in our system. We can do the same thing now for our add, except if you recall from your notes here that to add a student, we must have a total of 7 arguments. And particularly then, the string compare I for argv square brackets 2 should match the add. And then here what we'll do is we'll just simply say printf note adding a student, and we're going to just start off with 1% s. You can always go back and add more to be able to see the remaining pieces of information here. But in this case, we'll go ahead and add a student with ID, and we're going to just simply blindly accept or blindly put in then this argv square brackets 3. In other words, whatever the 4th argument was, we can then check for the remainder information as well. For the remove, we can actually go back and borrow the is-a option. In this case, then we would simply want to remove, and we can, once again, borrow the printf. And in this case, instead of verify that the information exists, we want to remove whatever entity or whatever student with the ID corresponding to whatever was passed as argv square brackets 3. The last scenario then that we're going to want to cover with our student is going to be when we are sorting them. And so that's going to involve 5 arguments utilizing our string compare I. We're going to need to verify that our argv square brackets 2 does in fact match our sort switch. And if it does, then we can go ahead and specify here that note sort the students with, and we might as well go ahead and include both arguments here just to make sure that we're passing them correctly. And the argv square brackets 3 is going to simply be the field that we wish to sort by, and then argv square brackets 4 is going to represent the string that will ultimately need to be converted into an enum of either ascending or descending. At this point, we should have at least handled all of our switch combinations that we are initially addressing. So we probably need an else here. And this else is going to be slightly redundant, but it is going to be an implicit call for help, much like in our earlier triaging of our first level of switches. So this is an implicit call for help. You could, for instance, get a little bit more specific. In other words, that they figured out that their first tier was supposed to be student. And then at that point, you could offer them custom help for the student switch. The disadvantage, if you would, of using this tiered structure is that it requires a few more implicit calls for help. In other words, we're going to have an else for each one of our nested branches here, but it avoids then that flat if structure where we have all of our ifs, else ifs on one level. So it's sort of a little bit of a trade-off here, but not a significant one. At this point, though, what you can do is you can actually go ahead and copy all of your code here for our student. And what we want to do is we want to recognize the differences between the student and the course. And to do that, what I'm going to do here is I'm actually going to open up another notepad. I'm just going to simply paste all of this in here. And if you take a look between the student and the course, really, it's just going to be any reference to a student, except for when we add a course, the number of arguments jumps from 7 to 9. So what we can do here is just do a Control H, and everywhere we see student, we simply replace it with course and replace all. And as I mentioned, wherever we have the 7 here to add, we need a total of 9 arguments for a particular course. At this point, we can go ahead and do a copy or a cut even. And we can very carefully graft this in under our course. And now you can sort of see the advantages of using this nested structure. That does mean that you're going to have a little bit of redundancy, as I mentioned, with the help, but that's not too terribly bad in this particular scenario. We can do the same thing once again now for our student, and then sort of morph it into our registration by just recognizing then the similarities in the patterns. There's the display all. The display, of course, has a different argument count, but what we'll do is we'll begin by simply changing every reference to student to registration. Mostly this is in our comments. And then our argument count simply needs to change. And so we'll go ahead and start by grafting this very carefully in here. And then let's think for just a second then about how does our argument count change. There we go. And see if we can't split our screen effectively here. And using our notes from earlier, display all does not in fact change. Our display of a single registration does. It changes from 4 to 5. We could probably argue at this point that we'd want to display both the course and the student information. So we'll go ahead and update to include both of those switches, both of those arguments. The ISA also changes to 5. Likewise, we could probably make a good argument that we would want to update our prompt here. And now for the add, if you recall, we only need to have a total of 5 arguments. And at this point, then we probably also want to update our printf to include both the third or argv square brackets 3 as well as our argv square brackets 4. The same with our remove, because you recall that we're going to need both the student and the course information to be able to remove a registration. Remember, once again, that just involves changing them from active to inactive. And then lastly, what we want to do is we want to look at the sort, and the sort doesn't really change at all. It's just simply going to be based on the field and the order, so that results in no changes in our switch triaging. And at this point, we can just simply decide whether we want to go ahead and handle the additional bonus switches. I'll actually cover these in another video, but we've done some of the work already toward handling these. At this point, the only thing that you need to do is update your help. And I'm going to get us started on this, and then I'll leave this as a to-do for you. But basically what we want to do is leverage the arguments that I've given you. And in this case, then we can put in the help a little bit of a description about what a particular function does. So in this case, it simply displays all students. And then we can do one more. Once again, just to get us a good solid start here, we want to display a particular student. So we want to provide then the student ID. Now keep in mind that you won't actually be using these brackets. This just indicates that these are parameters to our executable. And in this case, this is going to display a single student. And if you get a little bit further into this, once you get the first set done, you will once again discover that you could probably do a little bit of copying and pasting. At this point, what I'm going to do is I'm going to encourage you to go ahead and pause the video, go ahead and complete your help, and then we'll rejoin in just a couple of minutes so that we can see that we are all on the right track. All right, hello, welcome back. Your help should now look something like this. Also, if you went through all of your different options with your help, you probably discovered that we accidentally jumped over the change grade option for the registration. If you go back to your notes, you'll see that that required 6 arguments. So if we go up here to the branch of our first tier switches that involve the registration, we can jump in here now and we can add one more option, and that is going to be if our argc is going to be equal to 6 and our string compare I of argument number index equal to 2 matches a change grade, then we can at least identify which registration we're trying to change the grade for. And I would argue that optionally what you could do is you could include that third argument. In other words, we need to have both the course ID, the student ID, and also the grade. Now keep in mind though that initially this is going to start off as a string, and you ultimately want to convert it from a string then to a integer. But for right now, we will just simply leave it as a string just for the purposes of testing our switch capabilities or our triaging capabilities. At this point, you can go ahead and build it. And then what you should do here is go ahead and start opening a command window. And we're going to go ahead and cd over to our new project here. This is going to be under the courses, under EE233. And then under my projects, I'm going to be looking at my student course registration system demo, going down the dist folder and into debug, into MinGW. And you'll see here that I already have the files that I was mentioning earlier, my courses.csv, registrations.csv, and the students.csv. At this point, then, what we want to do is we just want to test capabilities of our demo executable. If we run it with no switches, we should see our help. If we run it with /h, we should see our help. Run it with /?, we should see our help. If we put something, we need to do numbers, just something there, we should see our help. So everything, at least for that first scenario, seems to be working right. We can now look at our student switches, and student by itself won't get us anything. We instead want to do something like /student/display all. And you can see here that not only do we get the list of arguments, but we also get the message that says display all of the students. We can do the same thing with display, and then we're just going to put in a ID here, in this case mine, and you'll see that it's going to try to display the information for G. Myers. You can continue to do this with all of your switches. So for instance, add should complain that does not have enough arguments, thereby bringing up the help. Remove, of course, should work if I provide a ID, and so on. And this is what you would want to do now, is to make sure before you go any further that all of your command line switches work. So hopefully you found this video useful. As always, if you have any questions, comments, or concerns, feel free to email me. And thank you for watching.